So here we have a non-right triangle. So with a non-right triangle, we should look to see if we can use either the sine law or the cosine law. So in this case here, we have angle opposite and side opposite side pairing. That means that we can use the sine law. So in this case, we have angle, angle, we have side, and we have side. So that means that we can use the sine law, but we have to be careful of the ambiguous case. And in fact, when we take a closer look at this, we can see that there is this possibility that this 7 centimeters can be drawn in this direction, just like maybe like that. Okay? And that means that there are two possible triangles that can be done here. So we do have to watch out for theta 1, theta 2. Okay, so there's going to be multiple steps to this. So the first thing is we're going to take that side opposite and angle opposite and set up a sine ratio. So we're going to do sine of 22 degrees over 7, and that's going to be equal to, we're going to pair up this side and this side here. Okay, so we're going to say that, or that angle. So sine of angle C over 10 is equal to that ratio. So once we have this ratio, we're going to then solve for the angle C. So we get sine of angle C is equal to 10 times sine 22 degrees all over 7. We can type that into our calculator. So we end up with 10 times sine 22 degrees divided by 7. That gives us a sine ratio of 0.535. So we have sine C equals 0.535. Okay, and then we're going to arc sine this. So angle C is equal to the inverse sine of 0.535. We're going to call that C1. Okay, and C1, when we arc sine this, we end up with 32.35 degrees. So angle C1 is equal to 32.35 degrees. Now I'm just going to, at the same time, find C2. So C2 is going to be this other angle here. We'll call that C2. And this one here we'll call C1. So angle C2 is the supplement. So angle C2 is going to be equal to 180 minus C1. So C2, we do 180 minus C1, we get 147.65. So 147.65. Okay, so that makes angle B, we'll call that one B2. Angle B2 works out to be, when we add it to 22 degrees and then subtract from 180, we're going to end up with B2 as 10.35. So this is going to be 10.35 degrees. And then we'll also work out B1, which would be this angle in here. That whole angle we'll call B1. So angle B1, subtracting from 180, we're going to go 180 minus 32.35 minus the 22 degrees we're given. So that's 125.65. So 125.65 degrees. Okay, so then we have to figure out the length of the C1, length of B1 and B2. So the length of B here is that short side. We'll just kind of do it like that. And length of B, we can do as this side as well. Okay, so that would be B1 and this would be B2. Okay, so we'll do B1 first, and we're going to use the sine law to find the length of B1. So we have the angle now. So we're going to go side B1 divided by the sine of the angle. In this case, it's 125.65 degrees. Okay, and that's going to be equal to an equivalent ratio here. We'll use the 22 degrees that we had to start. Okay, so we're going to do 7 centimeters over sine of 22 degrees. Okay, and then working out B1, the length of B is going to be 7 times sine of 125.65 divided by sine 22, and that's going to be 15.18. Okay, so I'll just write this out as 7 sine of 125.65 divided by sine of 22 degrees, and that works out to be 15.18. Okay, so length of B1 is 15.18 centimeters. And then we'll do the same thing for B2. Except for B2, we're going to use the sine of the other angle, 10.35 degrees. And again, we can set that up with sine 7 over sine 22. Okay, so then B2 is equal to 7 times sine of 10.35 over sine of 22 degrees. And working that all out, we get 7 times sine of 10.35 divided by sine of 22 degrees. And we get 3.3435 when we round that. Okay, so the length of B, that shorter length, okay, in the picture here, this length right here, that length is going to be 3.35, and the longer length, this longer length that we're talking about here, this longer length here is going to be 15.18 centimeters. Okay, so I should make sure that's in centimeters.